HANA is in-memory database which can store both row
Mm,
store as well as column store.
mhm,
And what I mean to in-memory is that
mm,
all the data
mm,
it stores in the uh, main memory, and that is
mm,
the RAM.
mm,
And that is how it is bit different than other database, and especially for um, for the data which requires immediate reporting and all those purposes, this is
mm,
the very good
mm,
database.
mm,
So
mm,
yeah, so well, that is what I can say in a brief
mm,
what's called intro of HANA.
mm, mm, mm,
So
mm.
yeah, yeah,
Okay.
yeah.
So, okay, good. I think since you use the word in memory, I'm impressed with that. But what is that in memory concept? So, what exactly is that in memory in HANA?
The data which is being used by the database, like the
Mm,
actual data, it resides in the RAM. So what
mm,
happens is that rather than going into a hard disk or in a file, which takes more of a time, here
mm,
the RAM itself is
mm,
using the
mm,
memory. So
mm, mm,
it is the processing will be much faster than
mm,
the usual conventional databases.
mm, mm,
So,
mm,
and there is also some kind of persistence layer,
mm,
which I see that
mm,
interval there is a backup is going on between the
mm,
log and there.
mm, mm,
So that is what the what you
mm,
call main difference between other databases and HANA.
mm. Yeah. So
Yeah.
absolutely right. HANA is a in-memory database. And although you use the word column-oriented, row-oriented stuff, right? So,
Yes. Yes.
what is the difference between that? Like, what do you feel? What is the difference between this row store and column store?
Um, It's I have an idea, but it's very
Mm,
difficult for me to explain. But
mm,
what
mm,
I would say is some of the tables they
mm,
store in the row ways,
mm,
and some of them they do it in a column ways.
mm,
What I understood, like some of the what you
mm,
call
mm,
uh, to analyze it,
mm,
some it has to go through the entire row and search it, but
mm.
in the column wise you can go to that exact location and pick it up. That's what I understand, but I'm not so sure
Mm.
whether it's correct or
Yeah,
wrong.
yeah, yeah.
So yeah,
Mm.
yeah.
Okay. Partially
So
right, but small
yeah,
correction is
okay,
required. Okay.
okay.
Okay, good. Like, I just thought of checking with you, like, how are you explaining it so that I can tune accordingly. So I feel like
Sure.
you are almost right in almost whatever you are told, except in that last few points. So I'd be explaining the difference between column store and row store in today's topic. And HANA is a
Sure.
in-memory, which is again you had given me the explanation, so you are fair enough to understand that. And we have a terminology called persistent storage area, PSA we call it as. So are you aware of that PSA terminology?
uh no, this is new
Okay.
for me.
Okay.
Okay.
In HANA, we have a word called persistent storage area, which is being referred as the permanent storage disk. So
Okay.
we consider this in memory or the RAM as a temporary storage area because RAM have a property of losing the data whenever your hardware gets switched off or whenever your hardware get crashed or any kind of
Okay.
failure happens, right? So RAM is actually a temporary memory for you, and we
Sure.
say RAM as a volatile one. So its volatility makes you to go into your persistent storage area to have a permanent storage of data. If in case my data is not being stored in my persistent storage area, ultimately my HANA will lose the entire data when the power goes off. Right. So
Correct. Okay. Yeah.
always you should have a permanent protection of data. And to have that, we have this PSA. PSA in layman
Okay.
terms, you can just compare it with your hard disk, just for understanding
Correct.
purpose.
Correct. Correct. I got it. Yeah.
So
Yeah.
that
Yeah.
hard disk is a permanent storage area for you. Even if
Mm-hmm.
power switches off, your hard disk will
Data.
still load the data. The data will still be existing
Correct.
there. right? And that's a common
Yeah.
feature here. And also you have a combination of OLTP and OLAP in HANA. So
Okay. Okay.
what is OLTP and OLAP? Have you heard about it?
Yes, I heard about it.
Mhm. Mm.
Um,
Any few words on that?
DP, um, mm, like
Mm.
uh, yeah, I forgot actually
Mm.
that
Okay,
term
no problem.
for
Mm.
this one abbreviation also. Yeah.
Fine, fine, fine. OLTP is your online transactional processing, and OLAP is your online analytical processing. So,
Analytical. Okay. Mhm.
if you want to know that comparison, it's your OLAP is more related to your analytical activities. Your BW system is more
Mhm.
related with your OLAP part,
OLAP.
and
Yeah. Yeah.
your
Yeah.
OLTP is your online transactional processing, where you can
Okay.
compare your traditional systems like your ECC or your SEM research systems can be
Mhm.
related with your OLTP. So the purpose
Correct.
behind this is like in HANA, you have a combination of both OLAP and OLTP, and that makes
Okay.
sure you get your transactional activities as well as your analytical activities pretty fast and easy. In other words,
Okay.
I can also tell you your OLTP systems are more write optimized and OLAP systems are more read optimized. So when I use the word read optimized and write optimized, write
Mhm.
operations happen in short span of time, and more
Okay.
write operations will be happening in your OLTP systems. Just consider your ECC as an example. Regularly there may
Mhm.
be updates, inserts, and retrievals may be happening.
Yeah.
Similarly,
Mhm.
your OLAP systems will be optimized to have more read operations. Just consider your BW system. What
Correct.
happens there?
Okay.
It's an
Okay.
analytical system where they try to fetch the report. Your data would have been loaded earlier, and they'll be trying to
Mhm.
get the output through this OLAP system, right? So, in
Okay.
short,
Okay. Yeah.
this is what your HANA is, both OLAP and OLTP.
Mhm.
So
Mhm.
now at this point of time, I would like to show you a slide where I have to make sure you to understand that
Okay.
HANA is not only a DB for you. HANA is not just a database that performs the storage and data retrieval activities. It performs more than that.
Mhm.
It's
Okay.
something that can perform more functionalities apart from the generic DB functionalities, like for predictive
Mhm.
analytics, text analytics, streaming analytics, graphical analytics, spatial analytics, yeah, a lot of stuff.
Mhm.
So that's what we will be
Mhm.
focusing as we progress further in the unit. So this is just a introduction where I am
Okay.
just sprinkling up the concepts here and there. And that's what, if you could see in the
Mhm.
slide also, it's just a single platform for multiple applications in short,
Yeah.
right?
Yeah. Yeah.
And
Yeah.
when you look upon the HANA design, it's also completely different by design because it stores the complete data in memory, and the data has been stored
Mhm.
in a compressed format, and the data is also stored in the
Okay.
column format. Again, uh, whatever information I'm giving you right now is something that was popped up by HANA during the initial period. By any chance
Okay.
you are like when HANA came into market?
Um,
Mm.
it's a
Mm-hmm.
recent one.
Mm-hmm.
Just
Mm.
um, I think not much. Maybe
Mm-hmm.
5 years, something. I think.
When you say 5 years, like by which year you meant to say, like?
I
Mm.
maybe post 2000 somewhere. I think the very
Mm.
um, mm, designing was happening. I think after
Mm-hmm.
not exactly. I don't remember exactly, but it's
Mm.
very
Mm.
it's still developing stage. 1.0 somewhere it was released.
Mm. Partially right here
Uh,
and there. Actually, HANA came
yeah,
into
yeah.
market by 2011, so we are almost like nine
Okay.
years. right? And Hana is an
Yeah.
appliance that came 9 years back, and still
Oh,
many
okay.
many
Okay.
people wonder Hana is a new appliance. Unfortunately, it's not a new,
Correct. Correct. Correct.
it's an old
Okay.
one. And because
I
of
see.
the scarcity of the knowledge among the people, they
Uh-huh.
feel like Hana is very very new. It's not a new appliance so
Correct. Correct. Correct.
anymore. Hmm?
Okay. Okay.
And the reason why I came up with this year is like the futures, whatever I am showcasing in Hana is something that popped up during that period by 2011.
Okay.
Earlier we
2011.
were,
Okay.
yes, earlier we were having traditional databases, and
Correct.
some new features should have been brought up in Hana that should have made Hana so special, and people can accept the Hana to this point, right? So that's the main
Yeah.
point which you need to focus when Hana came into market and what made Hana to be a predominant database in the market. So
Correct.
when you see all
Correct.
those
Correct.
facts, the data been storing in a compressed format, and since Hana is so fast, it does not require any sums, any indexes, any views, or any aggregates, and that ultimately reduce the DB footprint. Now on this point, there's a
Correct.
question for you: what is a database footprint?
Database footprints.
Yes.
Indexes, I know.
Okay. Any
Yeah.
thoughts on database footprint? You can guess, even if it is wrong,
Um,
I will correct you.
um,
Hmm.
Footprints. Um,
Hmm.
I'm not able to recollect of any of the this thing.
No problem, no problem. Because the
Yeah. Yeah. Yeah.
reason
Yeah.
why I pop up questions is like, if in case you have any
That's
thoughts, you can share then and there
yeah.
so that I can correct you.
Correct.
And I
Correct.
would be seeing
Yeah.
the way you respond, right? Based on that, I can also judge what is your
Correct.
understanding
Correct.
capability. That's the main reason.
Understanding. Yes. Yes.
Right? So no worries,
Yeah.
even if
Yeah.
you're wrong or
Understanding.
correct. Huh? Yeah.
Yeah.
So
Yeah.
footprint is nothing but the volume of data occupied in your database. Okay,
Yeah.
no
Yeah.
worries. I'll proceed further. So I just use the word
Yeah.
DB footprint, which is something you need to remember for your interviews or certifications, where the database
Yeah.
footprint is in question. And
Yeah.
to repeat, DB footprint is this total size that is being occupied by data in your database. And
Okay.
this terminology will be used multiple times as you progress further. So just remember this terminology. Okay.
Yeah. Yeah. Okay. Okay.
Everything has
Okay.
been calculated on demand here in your main memory, and that's also a main reason your DB have a combination of OLTP and OLAP.
Oh, AP. Okay.
Now, I just use the word columnar databases, and I just told you by 2011 HANA came into market. It came up with all these
Yes.
features. So, by any
Yes.
chance, if I ask you why not other databases came up with this columnar format before HANA introduced this? Why they didn't brought up that feature? Any thoughts on that?
Um. um, my understanding, or my, I can say guesswork, is that because there was huge time was taking for, especially for the BW reporting, or those kind of reporting thing. So SAP was trying to come up with the faster methodology where they can pull the data and do the reporting, and you know so that that was, I feel that is the main constraint where SAP put effort on uh, building up new technology, and that is where I feel HANA has came into, you know,
Mhm,
into being. So
mhm.
I feel that is the main reason for this.
Okay. Not exactly. There were some problems in your
Okay.
columnar databases to be actually, but good. You came up with some suggestion. So in HANA,
Yeah.
you try to
Okay.
sort out that issue. So I would tell you what was the major issue that was existing in a columnar DB. It was your concurrency issues. When I say concurrency issue, let me give more light on that. So you are trying to access a table. Maybe you're trying to access a particular row in a table, and you're trying to edit an
Okay.
entity in that row. Hmm. I have another user
Correct.
who is located at a different part of region, and he is also
Mm-hmm.
trying to access
Mm-hmm.
the same table, same row, same entry. Now, will he be able to edit it?
Edit, no.
Okay. Why? What happens?
Yeah. The first user is already has logged into it, so he's trying to edit. So
Mm,
he can only read
mm,
the data,
mm,
uh, but not edit it.
mm. Correct. So that's the problem with your concurrence issue. And if we consider
Mm-hmm.
this issue, think in a big picture. HANA is not a
Yeah.
small database. It have lot of data. More and more users are working on it. So let's
Mm-hmm.
consider one table, because ultimately end of the day database have tables, right?
Tables,
Whatever the
yes.
database
Yes.
underlying components will be tables, and tables is going to have that
Tables.
data. So
Mm.
when you consider your HANA database, the
Mm-hmm.
tables that resides inside your HANA DB will be large, will be small. It's dependent, right? And when
Yeah.
we
Yes.
consider, for example, we have a large table where a lot of records are residing, like millions of
Mm-hmm.
records are residing.
Yes.
Now,
Yeah.
if I want people to access that same table, they can do editing, they can do deletion, they can do addition, whatever it may be. But
Yeah.
if you have this concurrency issue, what happens? Everyone need to wait until the
Wait.
first
Yes.
user completes their activity. So we never
Correct.
know how
Correct.
long
Correct.
the users will be going to take some time. Maybe the first user may be processing the table for 8 hours, but the second user
Mm-hmm.
hardly need 5 minutes to do a small task in the table. But it is not
Yes.
fair for that second user to wait for 8 hours till he completes, and then this guy goes and do the work, right? This is
Okay.
what
Yes.
it happened in your traditional databases, and that made your response time to be high. If you see in those
Okay.
days when you had your Oracle database or Sybase database, and if you're trying to process millions of records, you could be able to
Mm-hmm.
see multiple issues, like time being in under wait mode, or
Yes.
processing response time has been very very high, or
Yeah.
people need to wait for a longer period of time to fetch the record. You could see a lot of
Yeah.
issues there. All these were mainly because of this concurrency issue. In HANA,
Okay.
we have sorted out using a concept called MVCC. So this is the next interview question or your certification question. Have you heard about this MVCC in HANA?
MVCC is somewhere I have heard, but
Mm, mm,
VCC, that this I remember this terminology, but
mm.
not fully understood. I'm just
Okay.
uh,
Okay.
yeah, yeah.
MVCC is nothing but multi-version concurrency control. So as the name
Okay.
suggests, it have multiple versions, and that controls this concurrency. So that's the abbreviation of
Okay.
MVCC. So this is a concept
Okay.
in which this concurrency issues have been sorted out. Now, when this
Mhm.
MVCC concept is adopted, what happens in HANA? You have a user who is trying to access a table. He gets the version
Mhm.
number one of that table. Similarly, if I
Okay.
have a second user who is trying to access that same table, he'll be getting the version 2 of the table. So we have that
Okay.
continual versions. Each user gets their own version, and they can do their
Mhm.
activities parallelly. So in that case, your concurrency issues have been sorted out completely.
Oh, okay.
Any
So the
doubts?
person who
Yeah.
um, in this multi-version
Mm,
concurrency the,
mm,
concept,
mm,
if three user is editing the same data, same
mm,
table and same data, so the
mm,
last person uh,
mm.
who's who's who edits, that will be the final data, right?
Whoever commits, that will be the final data. The last committed
Ah,
transaction will be the one. For example, if user 2
okay,
commits,
okay.
then that will be the
Hmm.
final data for other users.
Okay, 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 okay,
On
okay.
top
Fine,
of
fine,
that,
fine.
user 3
Oh,
can do this commit.
do his commit. So
Yes.
the last commit will be the final data.
Yes, correct.
Correct. Okay, okay. Fine,
Okay.
fine, fine.
Clear with this
Yeah.
MVCC? Very, very
Okay.
important concept.
Yeah, yeah. I got it.
Okay.
Got it. Yes.
Yes. And now you also have some
Yeah.
kind of performance issue in your raw store data, and that was also elevated out using a concept called delta storage in your HANA. So have you heard about this delta store,
Mm-hmm.
delta merge concepts?
Yes, I heard the delta storage and delta merge.
Mm, mm,
Uh, in the
mm,
memory,
mm,
you have the data, and the one which you are editing,
mm,
that will be, again, it will be stored in the log area.
mhm,
And the in the log, whatever the editing is happened, it will happen there. And
mhm,
once the final commit happens, it will go to the in memory,
mm,
main memory, and then it goes back to
mm,
um, the uh, disk. So
mm, mm, mm,
I think this is where the delta merge comes from, the
mm,
log
mm.
to the main memory in the same segment. That's the
Mm.
delta merge, I think.
Okay, okay, no
Maybe
worries. So
I'm partially
delta,
correct.
yeah, yeah, yeah. You are actually partially right because delta merge talks about something different, more on the memory management topic. So what I will be doing is like
Correct.
this delta merge and delta store concept. I am parking it aside, and will be covering in
Okay.
detail on our memory management unit, where I need to explain more topics
Okay.
before I explain this delta concept. So since this is an
Okay.
introduction unit, we are trying to sprinkling the concepts, terminologies here and there. So that's the ultimate agenda here. So just
Yeah.
consider this delta merge is a concept which is existing in HANA, and this is
Okay.
exclusively used to sort out the performance issues in your raw store format. Okay,
Okay. Okay. Yeah. Yeah.
fine. And have you
Mm.
heard about this thing, ODBC and JDBC standards?
Yes. ODBC and Jdbc.
Okay. What do you
Yeah.
think? What are they?
Uh,
Mm,
ODBC. Online database.
mhm,
Um, and this is Java based. That
mhm, mhm.
uh, it's a very long, very
Okay, okay. No
long back. I
problem.
said,
No
yeah, yeah,
problem. No problem.
yeah,
So
yeah.
ODBC is your open database connectivity and JDBC is your Java database connectivity.
Database connectivity. Yeah.
Okay. The reason why I use these terminologies are like you have the common standards, and these are the two
Correct.
major standards that you have in market. Apart from that,
Mm-hmm.
you have some standards that is being supported by HANA like JSON, MDX, and REST. So this is again an
Mm-hmm.
question to be remembered for your exams and all those stuffs. The sub
Mm-hmm.
standards that is being supported by HANA. So you have
Okay.
MDX, that is a multi-dimensional expression. You have JSON, that
Okay.
is your JavaScript object notation,
Java.
and you
Mm-hmm.
have a standard called REST, REST, representational
Mm-hmm.
state transfer. So just remember all
Okay.
the standards name. We will be again focusing more as we progress further in the units. So just
Okay.
remember the various standards supported by HANA. Okay,
Okay. Okay. Okay.
fine.
Mhm.
So at this point
Not
of
like
yes,
other database. It supports many standards, right?
yes, yes, yes.
Okay. Mhm.
Okay.
Okay.
So
Okay.
now I am showing you a slide where the innovative features is being exposed from the HANA perspective.
Mm-hmm.
So if you could
Mm-hmm.
see here, the row store and column store, which is something we will be explaining in the next slides. So this is the major innovative feature that you have in HANA, and this data compression,
Okay.
partitioning, new aggregates, and delta storage. So all these five concepts are the five major innovations that brought up HANA to be a successful one in the market. Mm. And
Okay.
similarly,
Mm.
when you see from the hardware innovation perspective, you have this multi-core architecture. So when I say multi-core architecture, it is a generic word. These days, we people are purchasing our smartphones and laptops. So if you see
Yes.
long days back, we were having a dual-core processor. Then we got into
Yes.
quad-core, then octa-core,
Quad core.
right?
Yeah.
As
Mm-hmm.
the
Yeah.
number of
Yeah.
cores are increasing, the processing speed gets expands, and HANA
Yeah.
performs everything in short span of time. What happens here, whenever the data volume is getting increased, that is going to give you a major bottleneck in your data transfer. For
Yeah,
example,
yeah,
you have your input output transfer rate, that is your IO rate, from
yeah.
your storage disk to the servers, will be not on par with your data volume, and because of that users may experience slow
Slowness.
transactions.
Yeah,
And to
yeah, yeah.
overcome these performance bottlenecks, we have to redeploy the architecture in such a way that we can use these recent innovations, whatever you could see in this slide, and we could use a parallel processing format on multiple cores, and more data can be stored in the form of a compressed format and main memory. So when we
Okay,
see all those stuffs, a kind of a different pictorial representation to show you the same part,
okay.
what
Yeah, yeah.
happened so far and what is the current scenario. So in the past,
Okay.
a lot of records were being input, but it's a kind of a funnel like structure where
Mm-hmm.
it's a FIFO strategy. What is FIFO? Have you heard about FIFO?
No.
It's FIFO is nothing but first in, first out. So whoever comes in first, they
First in,
goes
first
out
out.
first.
Okay,
So
okay,
in that case,
okay,
it's a form of
okay.
a queue model. So every request gets
Mm-hmm.
input from here, but the output funnel is very, very slow and low because of this funnel model.
Mm-hmm.
Mm. And
Okay,
for example,
okay.
this input request needs to wait till all these requests are getting processed.
Correct.
So this was the scenario again
Processed.
in
Correct.
the past.
Mm-hmm.
People were waiting
First,
for
yeah.
longer time whenever they were trying to process
Mm-hmm.
something in their Oracle database.
Yeah, yeah, yeah. Correct.
Yes. When we consider
Yeah.
the current concept in HANA, it's completely sorted out.
Mm-hmm.
You have multiple cores,
Okay.
multiple processing has been happening, parallel processing has been
Mm-hmm.
happening. So we don't want to wait until and unless someone finishes the record. And we have this row store column store format, partitioning, compression, and delta storage in this
Partition.
memory.
Partition.
And because of that,
Mm-hmm.
the more data can be stored and more data can be processed in short span of time. And it was very, very
Yeah.
easy for processing at a shorter time span. So all these innovative features made HANA to be successful in the market compared to this
Mm-hmm.
past scenario. Any doubt so
Traditional.
far?
Yeah. No. Yeah.
Okay, all clear?
Clear. Yeah. Yeah.
Fine.
Yeah.
Okay. So one more point to be remembered again for your interviews. We refer HANA as an ACID compliant database. By any chance, have you heard about this ACID concept in DB?
Yeah. 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 Yeah.
What is ACID?
Um.
Mhm.
Um. I said each has its letter has atomic uh, mm, asset compliance.
Yes. How do you explain that?
It is a whole database where the data uh, will be whole complete. I mean, after the completion of the entire transaction, it will commit the data,
Mhm.
and there is that is one that is one of the feature atomic, and
Mhm.
um, that is one, and there are some five features that is the main thing.
Mm.
I remember.
Mm.
Um, Certainly, I'm not able to recall that, but
No, okay. Okay.
that is
Mm.
what.
Okay.
Yeah.
No problem. So ACID is nothing but atomicity, consistency, isolation, and durability.
Durability. Okay.
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 So we
The
refer
last one.
ACID as an acronym, and this is the abbreviation for ACID. And HANA is an ACID compliant
Okay.
database. That means
Okay.
your data is being 100% reliable. Data is being
Okay.
100% accurate. Data accuracy, data integrity, data reliability, whatever it may be, it is 100%
Okay.
because of this ACID concept. And
Okay.
this concept is something that you need to give us an answer. If someone gives ask you a question like what gives you that assurance of reliability in HANA, or what gives the
Mm-hmm.
assurance for data integrity or data accuracy in HANA, so your answer
Okay.
is this one. asset compliant part.
Asset compliance. Yeah, yeah.
Okay. And asset is a property in a database, and asset acronym for atomicity, isolation, consistency,
Resolution,
and durability.
consistency, durability. Okay, okay,
Clear?
fine.
Fine.
Yeah,
Now we will see something on this row store, column store difference so that you get some more clarity here. So listen carefully
yeah,
here. In the left hand side, you
yeah.
have a table in which it has been
Mm-hmm.
considered as a row store format. You can see entries are stored in the form of your rows. Rows are nothing
Yeah.
but horizontal. And
Mm-hmm.
in the right hand side, entries are stored in vertically. They are the column store table.
Mm, yeah,
Hmm. So now let's
yeah.
consider this left hand side, your row store table. So in this
Mm-hmm.
case, what I can see here is like I'm passing out a query. Select a comma C from
Mm-hmm.
table
Yeah.
A. So since it's a row store table, and my query is more related with A entry and C entry. When you pick
Okay.
up this segment zoomed out, you could see
Mm-hmm.
as the CPU read it, it is reading in this direction anyhow, and
Correct.
complete entries are being fetched in which B
Mm.
and D is also included, but which is something I really don't want. Why? My query is
Correct.
interested
Yeah.
to get only A and C.
E and C. Yes.
So B
Yes.
and D is not really required for me. And in that
Mm-hmm.
case, it is not utilized effectively. There is a 50 percentage efficiency wastage here, 50 percentage
Mm-hmm.
usage is here, right? So I'm wasting
Correct.
50 percentage of the resources, 50 percentage of the time, memory, processing, CPU, everything. But
Correct. Correct. Correct.
when we compare it with our vertical alignment, that is our column store format, it gives me what
Okay.
exactly I need. Wastage has been
Okay.
completely sorted out. So it's effectively utilized. Throughput is 100 percentage. So this is just a very, very
Okay.
small example to make you clear. When you read,
Okay.
when you do the
Mm-hmm.
read operation, your column store table is optimized for read activities compared to your row store table.
Okay. Okay.
And this 50 percentage wastage is very, very high when you look in a
Yeah.
larger picture. Because if you have
Yes.
a lot of records in your HANA database, and if I say 50 percentage wastage of memory or processing or
It's
speed,
huge. Yeah.
it's very, very
Yeah.
high, which you would have
Mm.
effectively used for something else.
Yes. Yes.
Right? And in
Correct.
that case, I need to make you guys remember about this OLTP and OLAP again. I just use the word OLTP as write optimized and OLAP as read optimized initially. Now I'm going to
Yes.
say my column store table is the read optimized and my row store table is a write optimized. Why?
Right optimized. Okay.
If I give you three sentences, and if I ask you to write in a paper horizontally, the usual way in which you write,
Mm-hmm.
you would be
Mm-hmm.
taking a particular time to complete. If I give
Complete.
you
Yeah.
the same three sentence and if I ask you to write vertically, you will
Okay.
again do that, but you will take some time to write it. So in which
Correct.
part you will be taking less time to finish the work?
Okay. This one normal row based for writing.
Horizontal
Yeah.
one, right? Row based.
Horizontal. Yes. Yes. Yes.
So whatever language or whatever it may be, whenever you
Correct.
do that row format based model, your write operation is very, very high, and write operation happens in a short span of time. So I
Okay.
would say your row store tables are
Mm-hmm.
write optimized.
Okay. Okay.
Okay. And
Yeah.
people will be using the word column store as read optimized, and the explanation is from
Mm-hmm.
this slide. I just told you why
Okay.
your column store is referred as read optimized.
Okay.
In this way, your row store are write optimized and column store is read optimized. Now, in
Okay.
HANA, do you have only column store or you have both, or how is it?
Uh, in HANA, few tables are column, and I think most of them are in row table itself.
Okay, can you justify that?
Um, Justify in the sense certain tables which require only for the like
Hmm,
BW reporting tables.
hmm,
Uh, they are meant for storing as a column wise for
hmm,
the read.
Mm-hmm.
purposes.
Mm-hmm.
So whereas other tables which are mainly for the usage of the data to be written over there,
Mm-hmm.
so goes into the row based thing.
Okay, it's actually other way around. In HANA,
Okay.
you have
Okay.
more entries stored in the column store format and very,
Okay.
very less
Okay.
entries stored in the row format. I will tell you why. I just
Uh-huh,
told you
uh-huh.
row store tables are right optimized. So whenever you input something,
Correct.
it
Mm-hmm.
goes in a row format, and whenever you read
Mm-hmm.
something, it goes in the
Mm-hmm.
column format. So generally, if you see in a generic angle, any
Okay.
database will be having more read operation compared to the count of write operation, right? Because no one is going to
Yeah.
do that read operation in a short period of time,
Continuously.
because multiple
Yeah.
read
Yeah.
operations may be happening by multiple users. But write
Correct.
operation,
Correct.
it
Correct.
may be a single write operation by one user, and he is not going to do the
Mm-hmm.
same write operation in the same entry. But when you
Yes. Yes. Yes.
consider the same section, more and more read may be happening there. So overall, if you see,
Mm-hmm.
count of read operation will be higher than the count of write operations. Correct?
Okay. Okay.
Think in that angle. If I say count of read operations is
Okay.
going to be higher, then count of the column store tables is going to be higher.
Going to be high. Yeah. Yeah. Mm-hmm.
Okay. So
Mm-hmm.
just think the basic concepts whenever any kind of questions has been popped up, so that you may not get confused. Because I could see you are knowing few facts here and there, but I think you're
Yeah.
just
Correct.
getting in a different wrong format whenever you're trying to give up the answer. I think the
Yeah.
main reason
Yeah.
is like that basic correlation structure is being
Correct.
missing out there. That's the fact here. That's what I
Okay.
could see here.
Yeah. Yeah.
So if you could
Yeah. Yeah.
correlate with the basics, you can
Basic.
get the
Okay.
clarity for
Mm-hmm.
every question,
Mm-hmm.
right?
Mm-hmm.
So in
Okay.
that
Yeah.
case, I would say column store data is high. Now, maybe a next question for you: how this
Mm-hmm.
conversion happens? If I have both row and column, how is the conversion happening?
Mm, row based to column based. You are talking about the conversion, or column to row based, because most of them are in column based.
Hmm. Okay.
Mm,
You made me to ask me a second question now. Okay. What kind of conversion will happen? Will it be row to column or column to row?
it has to be in column to row.
Why?
Um, Most of them will are column based in HANA,
Hmm.
and if you want to write those any of the entries in those tables, it has
Hmm.
to be converted to row.
Hmm. Let me put up with a layman example here. You have
Okay.
returned something. In that case, it was
Okay.
row store, and now people
Yes.
started reading it. Now it
Mm.
got converted into a column format, right?
Okay.
Now the
Yes. Yes.
conversion is from row to column, right? Because you are
Row
writing
to column.
something
Yeah. Yeah.
and people
Yeah.
started reading it.
Yeah.
That
Correct.
then
Correct.
just
Correct.
then, but you use the word column to row. Just consider it with your layman example. People are reading something, and
Correct.
when people are reading something, you are going
Mm-hmm.
to write something. When you write something, why should I convert something that I was reading into a written format? If you are going to write, well, you write in that paper, I am reading something, and why it is going to get converted into row mode? It is nowhere related to your write operation, right? Because if you are going to write something, you may be writing in a free space in that paper, and whatever have been already written, that is considered as a
Mm-hmm.
column mode, and people started reading it. It is just like a book. You have
Okay.
written a
Okay.
book and you
Okay.
have published it. People, we all started
Okay.
purchasing the book and we are reading it. Now you suddenly felt like you need to add something in that book. So in that case, will you again ask everyone to return the book and then you will do the write operation? No, right? You will directly write the book and you will be
Uh,
again giving a second version of the book. You are not going to
okay.
get
Okay.
book from everyone and
Mm-hmm.
going to refund
Mm-hmm.
the money on all those things, right?
Correct. Correct.
So
But
think in that angle.
does
Yeah,
it
tell
not
me.
take more time when it is column based?
Hmm.
Write operation may take more time, right? In that case.
Why are you going to write in the column mode operation? You are going to write in the horizontal way. You are going to write in the row store
Okay.
format.
Okay. 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 Mm-hmm. But
mm,
that row ways of writing it, that
mm,
has to be converted to column. That has to be
mm.
taken by care, right?
Yes. When you anyone
Ultimately,
want to read it, they need to convert it into column format. When I say they, HANA will
column
convert
format.
it into column format.
Okay, okay.
Clear?
Yeah, yeah, yeah,
So
yeah.
now, what will be your answer for my question? What kind of conversion will happen? Row to column or column to row?
Row to column based,
Row to
yes.
column. And you
Column
got clear
based.
with the concept, right? Okay,
Yes, 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 yes.
fine. So this is a very, very important.
I
Yeah, go ahead.
Yeah. So
Mm,
by doing this, the space will be occupied more, right? When I say
mm, mm,
it's a column-based table, I'm
mm,
writing it. It is going into a row-based, and again it is converting into column-based. Somewhere here,
mm.
the space will be occupied more rather than
I think again
compact.
you
Oh,
you
this
gave me a wrong statement here. Why there should be a conversion from column to row? What
not
makes it
column to row,
necessary?
row to column, row to column. I'm sorry.
Mm, mm. Row to column
See, there's a
conversion. Go ahead.
yeah there's a table which is having column based. I'm
Okay.
writing something,
Mm,
editing something or appending some information. It is going in a row
oh,
based way,
okay. Mm,
and it is converting from row to column
okay.
ultimately when it is committed.
Okay.
um, is there any space which is getting extra used or getting wasted or something like that?
Okay.
Because
When you use this word row to column, compression
yeah.
happens internally.
Okay, okay, okay.
Optimization happens, structural changes happens,
Okay,
architectural changes happen
okay,
because
okay,
you
okay.
are writing something horizontally and I want to show it
Yes.
vertically. So in that case,
Ah,
complete architectural changes happens internally.
okay, okay, okay. Fine, fine, fine. Okay.
Clear?
Yeah, yeah, yeah. Fine.
And now there may be a interview question for you in this based on this concept. People may ask
Mhm.
you, generally if you see, if you would have noticed, the time taken to start the HANA database may vary. Have you ever started HANA database in
Yes,
your,
yes, yes.
uh,
I have seen it.
how
Yeah,
long it
yeah.
takes to start your DB?
Um, See, with less data and that I worked on the Fiori
Mm.
database. It took hardly like 3 minutes or something. But whereas in of the EC system, it took some time.
3 minutes is okay. I think it's pretty good.
Yeah,
I think the data volume would have been very
yeah,
less there.
yeah.
Generally,
It
if you
was very
see,
less actually.
the
It was very
startup
less. Yeah.
duration of the database may take up to 20 minutes, even 30 minutes. Even I
Yes,
have
yes,
seen a
yes,
case
yes,
where it
yes.
will go up to 45 minutes.
45 minutes. Okay. I
Yes.
have seen
If
10
the data
minutes or
volume is
15
very,
minutes.
very
Is
high.
enough.
Very,
Yeah.
very high. Data volume
Okay.
is very high
Oh,
and it's not properly
uh-huh.
organized. So there may be a question for you to shorten the duration of the startup time. So that fact
Mm-hmm,
mainly
mm-hmm.
depends on your row store records. So if you have more and more row
Okay.
store records, the startup
Okay.
duration of the table, or sorry, the startup duration of your HANA database will be very, very high. And these row store records play a very, very crucial role in your startup duration of your HANA because
Okay.
row store record size should be very less as these records are going to be getting preloaded into your memory when you
Correct. Correct.
start
Correct.
your DB.
Uh-huh.
And when you
Okay.
stop
Okay.
your DB, as I told you, RAM have that volatile feature. It will lose
Yes.
everything what was residing earlier. And now
Yes. Yes.
when you are stopping your database, the contents residing in your RAM is going to be flushed off. Now RAM is
Okay.
empty. And now again, if I'm starting my HANA database, I need some kind of contents to be preloaded into RAM and only then my DB will
Mm-hmm.
be started. So as you are trying to load your RAM with more record, the time duration is
Mm-hmm.
going to be expanded. If
Okay.
I am
Okay.
going to load less number of records in the RAM, the time duration of HANA startup will be less.
Less. Okay. Yeah.
So in this way, I could say like the RAM and the roster tables is going to determine your HANA startup duration.
HANA. Yeah. 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 Mm-hmm.
Okay, clear?
Okay. Yeah. Yeah. Yeah.
Any doubts so far?
This was I really had this down because
Hmm. Hmm.
in my previous project I had two implementation of it.
Mm-hmm.
I was explaining yesterday about my brief
mm,
introduction. So
mm.
where I got more of a HANA exposure is the previous project, where Fiori
Okay.
was a greenfield implementation and ECC was a
Mm,
copy of the older version,
mm,
a separate box where
mm,
we copied
mm,
the data, and
mm,
from 1.0 to we upgraded to 2.0,
mm,
well, revision 36
mm,
that time.
mm,
And that is where I see that ECC took time, 10 minutes
mm,
to
mm,
15 minutes.
mm,
But Fiori, which was a greenfield, which was a fresh data, it
mm,
hardly took 3 minutes or 4 minutes.
mm,
So I was one. I I could not now I can correlate
mm,
my
mm.
experience now.
Understood,
So I
right?
was unable to even
Mm,
yeah.
mm. Okay, okay. Shoot out your queries then and there whenever you have any confusion so that I can clear it off then and there
Sure,
also. Okay.
sure, definitely. Yeah.
And this is actually a very, very important concept that you should be remembering as you go forward. So that's the reason I was
Mm.
giving you more generic examples so that you get that clarity. Okay,
Yes, yes.
fine.
Yeah.
My last slide for the day, something on this host part. What is a host according to you?
Mhm. Host is a I would say a server name where
Mm,
at the actual application resides.
mm,
With, with the name we can able to
mm,
connect to the
mm,
server. So which is
mm.
again it has its own IP address and all. With the name we should able to get the IP address and we can able to connect to it. Host name.
Oh, host. Mm. So host is
Yeah.
not only for your application; it can be for any kind of component. So host is a raw platform,
Yeah.
and HANA
Yeah.
can only be installed in Linux host. Hope you are aware of that.
Yeah.
Okay.
Yes.
So when you see from a host perspective, you have a concept of single host and multi-host here. I can install HANA in
Yeah.
multiple hosts also.
Okay.
Okay, it doesn't mean like I need to install HANA only in a single host. I can deploy it in a
Mhm.
multiple host, and I can make sure
Okay.
HANA gets connected easily when I have this multi-host model.
Okay.
Okay. The reason why I popped up this is like in your scenario, if I have multiple host or single host, there's a small architectural changes in the HANA. We have a dedicated unit on HANA architecture where we will be focusing on that section. But in this point,
Okay.
what I want you to remember here is like just this name server and index. Have you heard about this name server index server?
Yes.
Any information on that? Would you like to share something on this?
Name server. It has all the information
Hmm.
about the landscapes.
Mm-hmm.
Yeah.
Mm-hmm.
Yeah. I know these services when we start and stop. Also, we just go through the
Mm,
services which are running in the
mm, mm,
command prompt and all.
mm, mm, mm,
So name
mm,
server, it has all the information about the landscapes,
mm,
details
mm,
about that, and index server is the main thing which
mm,
takes
mm,
time to start. Yeah,
mm. Okay.
yeah, and comes
Yeah, I think you are
compile
absolutely
and
right. Index server
yeah.
holds the
Mm,
data. More data has been stored in
mm,
an index server, and name server is just a
mm.
label for you. It is having the information about this index server. Okay. So
Yeah,
just
okay.
remember, index server will be having the exact data volume, and it is going to be having more memory being consumed compared to a name server. And every node in your multi-host architecture will be having this index server in place, and your name server
Yeah.
will be just storing the landscape information. And in
Mm,
the HANA architecture, we'll be discussing more on this. But for the time being, just
okay.
understand even if it's a single node or a multi-node, every node will be having this name server and index server.
Name
But
server, index server. Yeah.
XSI server is a dedicated server. We call it as XS Advanced, for which we have a dedicated
Okay.
unit in which I need to explain a lot on this because it's a very, very new component with this 2.0
New
HANA
concept.
database. Earlier, you were
Yeah.
having XS Engine. Now you have XS Advanced. Again, in this
Yeah.
XS Advanced, you have a lot of additional sub components also. So we'll be focusing on this in our forthcoming unit. So we will ignore this exercise at this point of time. And the common thing is this host agent. What is this host agent? What is the purpose of this host agent? You could see in every host, correct?
Um, it is a
Mm,
it is one of the services host agent
mhm,
where
mm,
um, you know we used to for the communication purpose, host agent.
Mm, mm,
That is what
mhm,
I can
mhm,
for host agent is, I feel, I understand, is for
mm,
communicating between each
mm,
application. Um,
mm. It's only for communication.
Mainly for communication. That's what
Okay.
I understand. Yeah,
Okay.
yeah.
So host agent
Mm.
is actually a agent that is being deployed on host, as the name suggests. It's a security
Yeah,
that
yeah.
we have for our apartment. So no one can go and come without the knowledge of host agent. Just like the securities in
Okay.
apartment, no one can go in
Security.
and come
Okay,
out.
okay.
So whatever applications that you are going to deploy in the host will be
Okay,
under the host agent's knowledge, because host agent is going to take care of that appliances that has been deployed in the host.
okay,
So it will have all the
okay,
information about your operating system, application, database, and any other components that has been set up. And this host agent
okay,
is mandatory for every host. If I don't have a host agent in a host, it's the responsibility of the HANA admin to make sure the host in which HANA is deployed will be having an updated host agent.
okay, okay,
So that's the case. Host agent becomes a mandatory component in every host. And if you could see in this example, in this multi-host architecture, how many ever nodes I have, every node should have this host agent.
yes, yes.
Okay. If
Okay,
in case I am not
okay,
having this host agent, I may not be able to carry out my regular activities, as host agent is the only agent responsible to take care of this monitoring informations in the host.
okay, okay,
Okay.
okay,
And
okay.
this life cycle management is again a very dedicated unit in which I'll be focusing on this
Mhm.
HLM part. Hope you should have heard
Yeah,
about it,
okay.
since you told me you
Yes,
installed
yes,
HANA
yes.
DB, right?
Correct.
And
Yeah.
HANA Studio repository is just your repository for the HANA content. So this
Okay.
marks the end of the day one for you. And
Mhm.
if you have any queries, you can pop up then and there. And if in case you have any concerns in speed, or if you need more examples, or if you couldn't understand any concept, you can interrupt me then and there, so that I can make you
Sure, sure,
clear.
sure,
And I
sure.
think uh, you popped up the queries at the right time also. Still, any queries
Yeah.
you missed out to check with me, the topic
Um,
what we discussed so
I
far?
don't see. Yeah, yeah, yeah. Pretty clear actually.
Mm-mm.
I will just go through once again
Okay,
whatever the topics you have said. Yeah,
fine. I'll
yeah,
be sharing you the
definitely.
recorded version. I have initiated the recording as soon as I started the session. So I'll be
Yeah, yeah,
sharing you this
yeah,
recorded
sure.
version, and I'll be sharing the slide whatever I
Mhm.
have shown to you. And
Yeah,
tomorrow, yeah,
thank you.
bye,
Yeah,
bye.
yeah, sure. Thank you. Thank you. Bye, bye.